and welcome to today's science class. My name is Miss Peg. I'm going to be your teacher today. Today we're doing a little hands-on activity that's going to teach us about how water moves through a plant. So we have these lovely carnations here that we're going to be using. You will notice that the stem is freshly cut and split into two pieces on both carnations. We also have water, 2 clear cups, and both red and blue food coloring, and a spoon. What we're going to be figuring out today is, using these carnations, how water moves up through the plant. So what you're going to need to do is take your food coloring and go ahead and put it in the bottom of your clear cup. You don't need a lot, just a little will do. You're also going to do it with both the red and the blue. Then, once you've managed to do that, go ahead and add your water. You don't need a lot, once again, just a little will do. You will notice that my water immediately changed colors. I'm just going to stir for a few moments to distribute the food coloring through the water. Now, what I would like you to do is to go ahead and add both your freshly cut flowers to the water. But before you do that, I'd like to remind you that you are going to be observing what happens to these flowers in the next 3 minutes. You're going to go ahead and write down your observations. Make sure that you're paying attention to all parts of the flower. Don't just look at the petals, make sure you look at both the bud part and the entire stem. Once 3 minutes has elapsed, we'll go ahead and we'll share our observations as a class. So, ready? Add your flowers. Now, since your flowers have been in the water for 3 minutes, you're going to go ahead and share your observations. Once again, I'd like to remind you that share all parts of the flower. Don't just share just the petals. Yes, that's the pretty part and the part that smells nice, but we want to share all parts of the flower. So, what can you share about what has happened to your flowers over the past 3 minutes? Hopefully, you looked at the stem, the bud, and the flower. And you notice that inside the stem, right inside here, even if you pull it out of the water, it's turned a little bit red. Or, if you looked at the blue flower, it's turned a little bit blue. You might have noticed that moving up the stem, there's been a little bit of color change. However, it's only been 3 minutes, so not a lot has happened. If you take a look at the petals, you'll see that they're still nice and white, maybe got a little bit of brown on the outside. Maybe they weren't watered well. And you'll also notice that the flower still smells the same, and the stem's still mostly green. Now, I'd like you to go ahead and compare your 2 flowers that have been in the water for 3 minutes to this flower that has been in the water overnight. Now, this is red food coloring again. You will notice the difference between these 2 flowers. This one is extremely white. This one has some changes to it. What do you notice about the changes between your flower and the flower that's been soaking overnight? Hopefully, you've come up with a whole bunch of changes. If you look closely and you make good observations about the flower that's been soaking overnight, you'll notice that the petals have started to turn red on the outside. You take a close look at the bud has also started to turn red in places. Down the stem, especially in the joints where the stem keeps growing, is also red. And if you take it out of the water and open up the stem, you'll notice it's extremely red. Not just lightly tinted like ours were. It's extremely, extremely red. So, I'd like to ask you a few questions about this. Besides the changes in the flower, we're going to figure out how, asking our initial question, the flower, how water moves through the flower. So the way this works out is, if you notice, every time we go to the grocery store or the florist, we come home with a whole bunch of flowers, and the first thing we do is put them in water. There's a reason for that. Flowers need to be fed just like the plants outside and just like you yourself. Flowers receive their nutrients from the water that they're in. If you'll notice, these flowers take the water that they're in and they suck it up the stem all the way to the bud and to the petals, so the petals stay nice and full. If the flowers aren't getting any water, they're going to turn brown and die, which we don't want to happen. The way this works out is in the stem, there's these tiny little tubes called capillaries. And these capillaries go ahead and they use pressure and they suck up the water from the stem. This process is called osmosis. From the water that the flowers are in, up the stem, up into the bud, and up into the flowers to feed the plant. If you think about our trees outside, they use their roots in the ground, they suck the water up the stem, into the branches, and out into the leaves, and that's how our trees stay nice and green in the summer. But this process is, once again, osmosis, from taking the water and putting it into the plant, and the capillary action, those tiny little tubes called capillaries, sucking it up the stem and into the flower. In this case, because we used colored water, it sucked the colored water up the stem and into the flower, the reason why our white flower is now red. And eventually, our flower that we put in red water will also turn red, and our flower that we put in blue water will turn blue. So I want you to complete this sentence for me. Capillary action is the process in which... What's happening when we talk about capillary action? Hopefully, your answer is something like those little tubes using pressure to suck water up the stem and feed a flower. Now that we've done our great demonstration, let's think about a couple questions. Let's say you want to give someone a bouquet of flowers for Christmas. The only thing you can find in the store is white carnations. Is there a way you can make this into a Christmas bouquet? Hopefully you've thought, once again, like we did here, that you could go ahead and put your flowers in colored water. Red for the red in Christmas, green for the green in Christmas, and you could put those flowers in colored water, and overnight, just like this flower here, they would change color, and then you have a beautiful Christmas bouquet. I also want you to think about what happens if I take one of our flowers and I put it just in clear water, regular water, no dye whatsoever. What do you think would happen? Hopefully you came up with something like, the carnation's not going to change color. There's no dyes in it, but still, even though it's not colored water, capillary action is still going to be taking place. It's still going to suck that clear water up the stem, into the bud, and into the flower to feed the flower to make sure that flower lives. But in this case, because it's clear water, the carnation is not going to change color. Now, I want you to think about this tonight for your homework. Go ahead and think about what happens if I took a stalk of celery, stuck it in water that was dyed, let's say red. What would happen? Think about that, and come back tomorrow and tell me what you think would happen. Maybe we'll have a chance to test it out. So, once again, remember, capillary action, taking those little tubes within the stem, sucking up the water into the bud and into the flower. Colored water brings colored flowers. Clear water, not colored flowers. All right, remember about your celery, and have a good night.